Good morning students. Again we are here to discuss a very important part regarding our practical chemistry, and that is known as your types of chemical reactions. It is a very important concept while we will deal with the chemical reactions. Okay. Chemical reactions are classified into various categories. In this case we will discuss two such important reactions. The first one is your single displacement reaction. Students, displacement can also be treated as one form of substitution. So, single means one, that means in this reaction what we will find that a more reactive metal displaces a less reactive metal from its compound. So, that means a more reactive metal, when it reacts with a compound containing less reactive metal, it will displace the less reactive metal. For example, in this case we have put forward an example of iron. When it is allowed to react with copper sulphate solution, which is originally blue in color, we will find ferrous sulphate along with the formation of metallic copper. Students, this arrow in the lower direction represents the formation of a precipitate. We will get a reddish brown precipitate. So, if we take a close look into the example, we will find that just this copper from this copper sulphate has been replaced by iron. So, consider the product. In place of copper sulphate, this is your sulphate ion, students. This sulphate was initially attached with copper 2 plus, but in this case what we are observing that in the product we are finding ferrous sulphate. That means this copper is getting replaced by iron. So, that is why we will call it a single displacement. Only one displacement has occurred. Now, it might come to your mind that, sir, how will you determine that iron is more reactive than copper? That is why, students, we have written the reactivity series right at the extreme end of the board. The reactivity series starts with potassium and it ends with gold. This downward arrow generally refers that as we move down the group, the reactivity of the metals gradually decreases. So, it refers that potassium is the most reactive metal and your gold is the least reactive metal. Now, students, come to the original reaction. We can find iron and we can find copper. So, now we will move to the reactivity series. We will try to find the position of these two metals. So, we can find that iron is here and copper is placed much below than iron. So, according to the series, if we move down the group, the arrow is already representing the fact. If we move down the group, we will find that the reactivity gradually decreases. So, since iron is placed much higher in comparison to copper, so definitely iron is going to replace this copper. That is why we are getting ferrous sulphate along with the formation of this reddish brown precipitate of copper. Okay, students. So, now we are proceeding to this reaction and we are trying to maintain an activity for this. So, students, now I am having this copper sulphate solution in my right hand, which is blue in color. Already, students, it is written in the reaction that this copper sulphate will be blue in color. Now, this iron means we cannot put iron in the form of big chunks. Generally, iron will be presented or it will be represented in the form of iron nails. So, students, this is our copper sulphate solution which is blue in color. It is quite clear to us. And now, students, I am having some iron nails. Okay. This iron will be represented in the form of some iron nails. So what will happen students, this iron is now going to react with copper sulphate solution. So now students, I am pouring this iron nails into copper sulphate solution. So now with the progress of time, what we will find that as time progresses, it will be converted to ferrous sulphate and reddish brown precipitate of copper will be obtained. So if we wait for 5 minutes, 10 minutes, 20 minutes, finally we will get this reddish brown precipitate. So we are having the product. Students, you can compare the result. This is our initial case where we have taken copper sulphate, blue in color, and in that copper sulphate we have poured some iron nails. So with the progress of time, what we will find that this is the final product. We can clearly see, it is quite visible that those iron nails will be converted to ferrous sulphate and we are getting this chunks of brown color precipitate of this metallic copper. Okay. So that is the example of a single displacement reaction. So students, our single displacement reaction is over. We have written the examples and we have performed this with the help of an activity. Let us come to another important reaction which is included in our syllabus, that is your double displacement reaction. Students, you have to remember the difference. This is the single. Single means only one atom will be replaced by another atom. But whenever we are considering double displacement, that means here we will find two substitutions. Okay. So what we can say that in double displacement reaction, generally two ions exchange their positions with each other. When two ions they interchange their position with each other, that type of substitution we will call it as double displacement reaction. So obviously students, when the two ions will exchange their positions, then we will get two new compounds. Okay. So in double displacement, two ions are going to exchange their positions and finally we are going to get two new compounds. So the reaction has been written in the board. It is very excellent example of double displacement reaction. When potassium iodide, Ki represents your potassium iodide, when treated with lead nitrate solution, we will get lead iodide, a yellow color precipitate of lead iodide along with the formation of potassium nitrate. So here students, we can find that initially with lead, students look carefully, initially with lead there was nitrate ion and initially with potassium there was iodide ion. But consider the product. When we are focusing on the product, we are finding that with lead this iodine has been attached and with potassium this nitrate has been attached. So what we can say that this nitrate has come to potassium and this iodine has come to lead. So that is why we are going to have two different products. The color is visible just like the color of the stick which I am holding right now. Okay. So now students, let us move to the activity part and see whether we are having this yellow color or not. So students, now we are moving to the activity part. Let us check that whether on adding potassium iodide with lead nitrate, whether we are getting this yellow color precipitate of lead iodide or not. Okay. So students, right now I am having two solutions holding in my hands with the help of beakers. The right hand, my right hand contains your potassium iodide solution and my left hand contains lead nitrate solution. Students, it is quite visible that these two solutions are colorless. Lead nitrate is colorless and potassium iodide is also colorless. The solutions are taken in large quantities. So now we will try to transfer them in test tubes. Okay. So in first test tube I am taking a small amount of potassium iodide So, students, this solution is the solution of potassium iodide, and in another test tube, students, I am going to take this lead nitrate solution. So, okay students, now we are having two solutions ready with us. First one is your potassium iodide and second one is your lead nitrate. Now, we will mix both the solutions and see whether the color is yellow or not. What we have written actually in the board, whether this yellow color will come or not. So, we are adding, this is our lead nitrate, we are adding with potassium iodide. So, students, it is clearly visible that we are getting a yellow color precipitate of lead iodide, what we have actually told in the reaction. So, that is why student, these two reactions are very important, because we can find noticeable color changes during the course of the reaction. Thank you.